starting, I need to ask you 3 questions. First one, I need at least one person that is more comfortable in having this talk provided in English than in Italian. Okay, perfect. I just need one person. So, second question is about how many of you have ever trained a machine learning model using any tool? Raise your hands. Okay, used a pre-trained machine model? Should be more, technically. Okay, great. So I would say this is a good audience for this talk, because we're going to talk on how to apply machine learning capabilities inside your app without being a machine learning expert. My name is Alfredo. I work for Google Developer Relations, and everything you need to know about me is here. So, because it's a very low-level talk on machine learning details, let's start a little bit defining from a very high-level point of view what machine learning is. So we can say that machine learning is a way to learn from example and experience. Like the way we learn to speak our first language. Like, if you have kids at home, or if you remember when you were a kid, like you started to listen to something, to try to reproduce the sounds, and then first words, maybe correct or not, then sentences, and at the end, entire conversation. So machine learning, it's very, very similar. So we can say that machine learning is loosely based on the model human brains learn. It's something that tries to solve problems without knowing the specific solution. When we write a piece of code, we have the solution in mind. We write the code, and of course, we hope everything works as expected. With machine learning, we as humans, we don't need to figure out the solution before working on the problem. And of course, machine learning enables systems that improve over time. So those are 3 important characteristics of any machine learning model and algorithm. There are different kinds of problems you can solve with machine learning. One of the, let's say, most common nowadays is to have an input, can be any bit of information. You have labels, and then you apply a model, and the model returns a prediction, a percentage on how much these labels apply to the input data. For example, this is an image, so it's a piece of data, and how much the label cat applies to this image. It's, I don't know, 99% sure, 100% sure. Is it a dog? Maybe a dog is 0. Or it's like a brown image. It's another label, like the kind of color. Yes or no? So we return this kind of information. Or if we have a piece of text, tell me if this piece of text talks about sports, or it's about baseball, or it's from the New York Times or other newspapers. So these are all kind of problems you can solve with machine learning. Instead of a video, I want to have a general description of what's inside the video, the objects, the people, general topics like nature, and so on. So trust me, those are complex problems to solve. Okay, the fact that nowadays we have this information more or less taken for granted doesn't mean that they are simple. Even, communicating over the internet, it's super complex thing. Pinging a computer on the other side of the world, it's very complex. But luckily, because of many layers, we now simply don't care about this complexity. Someone else has solved this complexity for us. So machine learning is complex, but is only for experts. Well, I would say when machine learning more or less started in 1950, this is the first neural network computer in the world. And yes, probably you have to be an expert to interact with this computer, or at least an expert in arranging wires and so on. But if you look at Google repository, and if you count the number of model description files inside the Google code, you can see that there is an exponential growth of these files over time. And it has started more or less in 2010, when we finally had the computational power to run a proper neural network on a piece of hardware. And in the last 2-3 years, there were many more models in the Google code. And of course, there are a lot of products that are using machine learning inside Google, and a lot of more that are not like open to consumers. So because we have seen how machine learning is useful in a variety of different tasks, we think that it's important to democratize the usage of machine learning. So it doesn't mean that, make machine learning super easy to understand, because again, it's complex, but make machine learning as easy as possible to use. If we think about a machine learning problem, there are different, let's say, there is a spectrum, okay? Where in one side, you have a very general task, something that has been already solved by someone else, and you can simply copy the solution. On the other side of the spectrum, on the other extreme, there is a custom task, so a very specific need you and only you have. Example, I want to categorize this picture and recognize the kind of animal in the picture, or I have 3 different cats. I want to recognize the cat in the image, so the name of the cat in the image. This is very general, very broad, already solved by someone else. This one, probably no one else in the world has created something to recognize your cats in the image. Similar with text, I want to extract, different kind of attributes in the word, in the words in the sentence, or I need to understand if this is a sentence around programming, and if yes, what kind of Google technology are discussed inside the sentence. Again, very general, very specific. Google offers different solutions for every part of the spectrum, and in particular today, we will focus in this one a little bit, and I hope a lot in this one, okay? So, quick overview on the left, so my right, your left part of the screen. General models that can be used to, in your task. There are generally pre-trained models you can simply call and use with a REST API. Okay, so Google has done all the heavy lifting or understanding the models, creating the infrastructure to serve you whatever you need, and you simply call a REST API. There are several products, and more are added basically every week, more or less. This is just 6. There are now 7 or 8, if I remember well. Let's go through some of them. Cloud Vision. Cloud Vision is probably one of the most used. And with Cloud Vision, you are able to extract information out of images. For example, you can detect labels in the images. It's a cat, it's an elephant, it's a house, it's a skyscraper, whatever. And you can do text recognition inside the image. You have an image, you can extract pieces of text. You can do logo detection. Hey, I see a logo here, a brand or whatever. You can do landmark detection. Ah, this picture probably is from the Colosseum. Oh, this picture is from this famous landscape. This picture is from this mountain, and so on. You can do crop hints. You need to resize the image. So instead of doing random resize, you can ask to the Vision API, hey, what's the most meaningful part of the image I have to preserve in order to cut the image to this size or to keep this ratio, and so on. You can do explicit content detection, like, hey, maybe this image is not appropriate for this audience, and so on. You can also do face detection and a lot of other stuff. How to use this API? Very simple. It's a REST API. There are clients for a lot of languages and frameworks. This is just an example in Node.js. You initiate the object. You ask the kind of recognition you want to do on the image. In this case, I want to recognize face and want to recognize labels. And then you call the API, passing your image. This is, again, just one way. For example, you can store your images in Google Cloud Storage and then access to the images already stored in the cloud. You can decode the image inside your code and pass the image as a stream of a bytes and so on. So this is, let's say, the very, very core. I have an example. Let's see if we are able to go through it. Yes, I have the other monitor here. Okay, this is a demo. The link is on the slide. Let's see, for example, we have a stadium, an image of a stadium here. It's very woo effect. And again, in this image, those are all the labels detected with a percentage. So it's a stadium, and I'm pretty much sure it's a stadium, 98%. And other things here. There is a text, red. The cool part is that there are also phases, and they say, where are these phases? Here, the player over there. The API detected a face, and there are also other information. This is a landmark, and this is the Citi Field Stadium. So you can get a lot of information out of just a simple image. If you're speaking about faces, for example, you can see here face detection and point of interest in a face. And what's the reply? The JSON reply of the API? It's very easy. Face annotation, a polygon, where are the vertices of this polygon, so you can very, very easily get the information out of your image. Okay, let's go back to the presentation. Cloud Natural Language is another API, of course, to process text. What you can do with this API? You can extract entities out of the text, detect sentiment, positive, negative, and to what score, analyze syntax, and classify content in the text. For example, if you want to analyze syntax, every single word, how the words in the sentence are connected each other, and the attribute of every single word. It's a noun, it's a verb, it's a punctualization, whatever. So thanks to this, you can then pass this syntax tree to another NLP algorithm to understand the meaning of the sentence. You don't need to do all the grammar examination of the sentence. Classify content. Okay, this is an article. Tell me about what this article is. We are discussing in this article about sport. This is something about a baseball team, and more information will be provided just from this small snippet of text. Calling this API, again, it's super, super simple. You initiate, again, your objects. In this case, the data is in a Google Cloud Storage bucket, but you can pass your data, because it's a simple text, so you can even pass your data directly in the API. And you define a callback, and you call the annotate function. What is the reply? This one. You have the sentiment, you have the language detected, so you can recognize more or less 120 languages you can analyze, and here is the language detected. And if you ask for entities inside the text, the API tells you that, hey, in this snippet, they are speaking about Lawrence of Arabia, and it links to the Google Knowledge Graph entity connected to Lawrence of Arabia. So from this entity, then you can navigate the knowledge graph. And there is also a link to Wikipedia in order to better refer your entity. So it's not just, hey, I just extracted this piece of text. I extracted this piece of text, and this is the entity in the knowledge graph word referring to this piece of text. So you can do a lot of follow-up elaboration. This is the tokenization. So for every single word, you have a lot of attributes. It's like super long JSON to read. Cloud speech to text. You have an audio file. You want to transcribe what is inside the audio file. Well, you call this API. You have support, again, for 120 languages. You can both pass just a piece of audio or a stream, and the results will be returned real time. You have built-in noise cancellation, so you don't need to pre-process your audio file and remove noise, because it's already done by the algorithm. You can pass your context-specific words to be recognized. So, for example, if you know there are particular names or particular concepts that are only part of the domains you want to analyze, you can pass them to the API, and the API will take these words into account. And you have pre-built model. Hey, this is like a call center conversation. This is a help desk conversation. So this model helps to better recognize the different words pronounced. Again, how to call this one is still a simple REST API. So this is the endpoint. You can pass your audio file here or linked in a Google Cloud Storage. You add some configuration, like I want to, this audio is encoded using this codec, this is the language, this is the default model, and so on. So you can pass some parameters in order to improve the recognition of your model, and then you obtain the text, okay? The opposite way, text to speech. You have a piece of text, you want to have an audio voice of this text, okay? Basically what you have on, I don't know, Google Assistant. There is a written text, and you get the pronunciation of this text. Thanks to this API, you have 30 and plus more 30 and plus voices supported, and some of them are based on WaveNet. WaveNet is a neural network created by DeepMind, and instead of creating the piece of text, gluing together different pieces of audio recorded from a human, it's something created brand new from a machine learning algorithm. And it's now available in English for sure, probably French if I remember well, and Spanish, and the more will come. And this is the same neural network used again in Assistant and in other Google products. And consider that this network scored 50% more than any other algorithm in terms of generated text compared to human spoken text. Very easy, you pass the text, you define some parameters, the language, the kind of network you want to use, the output format, some other parameters like how quick it should be, whatever, and you obtain your result, the audio file with your result. Last but not the least, cloud view intelligence. You have videos and you want to categorize labels inside the video. Okay, this is a video about people in a conference or in the nature or whatever. Instead of doing this, I don't know, extracting random frames from the video and process these frames as images, you can do this across all the video. And the good part is that not only the labels are returned, but also where the labels are in the video. So from second 10 to second 12, there is a person, and so on. You can separate signal from noise. There is a change of scene, or here we have a landmark. Here we are inside a house. Here there is a party of people. So you can also jump in different pieces of the video based on the content of the video, and you can also classify content. If we have time, I will show you the demo later, but you can access and see this demo by your own. So we explore quickly what was in the right part of the segment. Let's move on the opposite part. So a very custom task you have to resolve by yourself. No one else has solved for you. Of course, there are a lot of solutions here in the market. What Google suggests is to use TensorFlow and Cloud Machine Learning Engine. In particular, TensorFlow to build the model, and Cloud Machine Learning Engine to train and serve this model. Let's go deeper. TensorFlow probably is the most common and known machine learning framework out there. It's on GitHub, it's open source. There are plenty of projects built on top of TensorFlow, and you can use it to build your custom model. But once you have this model defined, you have to train it, and generally train is the very expensive part where time, hardware, resources, have some important request. So what you can do, you can, once you created the model, you can train this model on Cloud Machine Learning Engine using the cloud of Google with the GPU, with TPU, so special hardware, tensor process unit, created to run TensorFlow training processes in a very good and optimized way. So you get basically the best without spending, tons of euros to just buy the hardware by yourself. And of course, Cloud Machine Learning Engine then serves you a model as a REST API. So you can also try very easily without creating your own infrastructure. Because this is a talk, again, not on the creator custom model, the introduction was very quick. Let's focus on what's in the middle of the model. So AutoML, what does it mean? That with AutoML, you can use some pre-trained model with your custom specific need. Let's say, for example, I'm a meteorologist, and I want to predict weather trends from cloud images. Why? Because we all know that some weather is also influenced by cloud images. There are different types of clouds, and I want to recognize them in the images I have, because I know that this pattern is identified by this cloud, and so on. If I pass these images to the Cloud Vision API, the Cloud Vision API tells me, hey, there is a sky in the image. Okay, thank you. There are clouds. Okay, thank you. It's daytime, it's blue, there is atmosphere. Okay, great information, but nothing about what kind of clouds there are there. Okay, so you can build your own TensorFlow model in order to identify your 10 different kinds of cloud, but you will need a lot of data, literally hundreds or thousands of images of cloud, categorize all of them, and so on. Or you can ask help to AutoML. AutoML, in its core, it's a way to automatize the design of machine learning models using machine learning. So yes, we are going deeper, like machine learning that teach other models how to better train on data. It's based on a lot of, in our case specifically, the workflow is that you have your images, some of the images with cloud more or less. Right now, you should have at least 10 images of the labels you want to for each label you want to recognize. So it's not like a huge amount, just 10. Of course, the more, the better, but you can start with just 10 images. You pass everything to the AutoML Vision, and AutoML Vision generate a model and a REST API to access this model. AutoML Vision is based on a lot of papers. It's not something easy. And here is just a subset of the many things that were required to create AutoML. And in order to test how this model is good, especially for image recognition, if you know a little bit of machine learning, you know ImageNet. ImageNet is like a huge database of images categorized with labels. And when people want to create a new model to recognize labels, they generally use ImageNet as a benchmark, saying, hey, those are the different models that are tested against ImageNet, and there is always a trade-off between accuracy and operations. So there are models that don't require a lot of operation, so they are very fast to run, but are not so accurate. On the other side, there are models that require a lot of operations, but they are very accurate. So it depends on what you need to do. You have different models. For example, these models here generally run on mobile devices, this one in different kind of hardware. Applying AutoML Vision to the ImageNet database created a new kind of model that outperformed all the previous human-created model, both in terms of accuracy and in terms of operations. So the black line here is what humans have done. The red line here is what a machine learning algorithm has done. So as you can see, there were several improvements. Okay, and by the way, you can use this model in TensorFlow under the repository with all the models. This one here is called the SLIM, and this one here is called the object detection. So it's something that you can use without even caring about why I was possible to create this model. So AutoML is still in alpha right now, but some customers are already using it, and this one is the one I like. Like there are a lot of images of animals in the wild, but animals, proper animals. So again, they want to recognize what animal is in the picture, not is a tiger or is a dog or is a cat. I want to know the name of this tiger. I want to know the name of this other animal, and they basically use AutoML to do this. So let's see a demo of AutoML. Okay. By the way, still an alpha. So this won't be the final interface. Everything will be integrated in the Cloud Console, in the Google Cloud Console. So take it like for what it is, an alpha. So you start, and here I already have some models defined. And the one we're interested on is the cloud. What I've done was I imported several images of cloud, more or less. We will see, stats later. And again, you can import all these images by hand, or you can put all of them in a cloud storage, Google Cloud Storage bucket, and say, please get the images from this path here. You then need to assign labels to the images. So this image is about Cumulus. This image is about another kind of cloud. And again, you can do this manually, or you can import a simple CSV when you connect the name of the image and the labels associated to the image. And this is the way you import the data in your model. Then here, you can define, you can have some stats about the different kind of labels. So you can see that there are 88 images on Alto Cumulus, 111 on Alto Stratus, and so on. You can also check more or less the number of, in a very more graphical way. So for Cirrus, we have way more images than for Stratus. And of course, there are some suggestions. As I told you, minimum 10 images per label is required to have sort of recognition, but the more is the better. You can also check, for example, the labels applied to the image. I want to know all the images with this label. And you can go through your data set. So again, I wouldn't say you don't even need to be a developer to understand this kind of interface. It's very, very easy. Then you can launch the train, okay? And you have two options. The first one is like, hey, Google offers you 1 hour of his, data center power to train with images that you provided, or you can go deeper and do more stuff. Should I put it bigger? Better now? Okay. You can provide again 1 hour of training time, or and based on the size of your label set and the size of your data set, you can access to this free model, or you need to pay something. Okay, and then you click train. Okay, something in background happens. So machine learning models that create new machine learning models, evaluate them in terms of performances, compare, did a lot of stuff. And what you have at the end, it's like an evaluation of the model that AutoML created for you. Evaluation, what does it mean? You can, based on the different labels, you can get, let's see, for example, these two parameters. Okay. We have very few for AltoCumulus. Cirrus was the one with more images. Yep, okay, yeah. So you have the precision and the recall. So there are typical parameters that you use to estimate how good your model is. We can go deeper, but I don't think we have so much time. But in any case, it's always a trade-off between precision and recall. And so you choose the trade-off that is good for you. And you can check these label per label. So if, for example, a label has a bad trade-off for your needs, okay, you can go back, find more images that has this label, pass them to the model, and retrain it again. Okay? So all the optimization of the different parameters and all the other things that are necessary to create a machine learning model, it's totally out of your scope. So you don't care about them because the algorithm will do them for you. Once you have finished, you can finally predict something, okay? And again, this is the interface, but because a REST API is exposed, you can even create a very, very simple program. I create something with Firebase here. You can upload a random image of clouds, and this is okay, and it will be recognized, okay, those are cumulus, and this is the percentage of cumulus, okay? So if you just wait a training time, you can create an algorithm able to identify your custom images in, let's say, a couple of hours, even less, without knowing anything about machine learning. So let's go back to the presentation. Okay, so when you can use AutoML Vision? Of course, when you have a limited expertise to build machine learning models, but in any case, you want to create something that is production ready, because from the different data I showed you before, you can understand if your model works in production or not, based on your needs. There are models where the precision and the recall threshold can be low, so it's okay, because maybe they are part of the pre-filter pipeline, so it's okay for you to have not so great precision numbers. There are other models that have to be precise, so you pass them more images, you pass them more data, and these models learns over time, okay? It's still in alpha. You can register on the website, and it will be available soon. Of course, AutoML, we saw how to apply AutoML to vision, but there are a lot of other fields where AutoML can be applied. Remember all the different APIs I presented you before, recommendation, video, translate, and much more. So I would say more will come, because it seems from the initial test not even more initial right now, but from the test that we have done in Google, that it seems a very promising way to create models. Instead of having only people in charge of creating these models, we can create neural networks that are better and better in creating specific neural networks, to solve your specific need. Just to wrap up, 3 things to remember from this talk. The first one is that you can use a pre-trained API to accomplish common machine learning tasks like categorization, NLP, translation, and so on. You can build your own image classification algorithm based on AutoML Vision. Or if you have a very complex very deep custom task, you can build your own model by your own using Tensorflow and training it and providing it, use it on Cloud Machine Learning Engine. Those are a lot of links because it seems like a small field, but it's huge. So there are a lot of links of different products, different things. There are also links to papers. And of course, if you're interested in Google technologies, just outside here there is a booth where there is the Google developer community. So people passionate about different Google technologies all over the world. This is the number of GDG all over Italy that you can refer to if you want to learn more on Google technologies and meet people while learning. And that's all my side. We can go through the examples, or we can ask, you can ask questions. Okay, let's go with questions first. Okay, and then you. Please go.
What about privacy concern about using this platform? Like, it's very intriguing, but what Google does with this data? And can you prevent Google from retaining it and using it?
Okay, because, no, this is a very good question. Were you able to hear the question? Okay, the question was, and correct me if I'm wrong, it's what is about privacy of the data I put in the model? Like, as for every Google product, cloud or non-cloud, you have the term of services and the privacy policy. So right now, the program is still in alpha, so you don't have a proper term of service and privacy policy in place. But as soon as, okay, you have, but it's temporary and only for the customer and people that are using it. But as soon as the AutoML will be in production, the term of service and the privacy policy will define exactly what Google can or cannot do with your data. No. You can, you can look at the pre-trained machine learning API to have an idea, but it's a different product. Maybe the things could be slightly different. I cannot, it's in the future, so I don't know.
How often do you change the models behind okay, the question is how often and if you change the models behind the pre-trained API, and if in my production code I can use one specific version.
You mean like Cloud Vision or the AutoML?
Everything.
Because
no.
In
the Vision, the OCR,
Cloud Vision, you
everything.
don't know. Like as a user of the API, you don't know about the particular model used in the moment you make the call.
Because if I build an app and I test it with this API and I see that it works for specific images, and then you change the model behind, maybe.
Yeah, I would say I see a little bit hard that we make predictions that are worse than previous ones. So unless there is some, but at the end you have, the Cloud Vision API it's thousands of labels, but it's a defined set of labels you're able to recognize. So probably whenever we roll out a new model, we also test if the predictions are still consistent with the previous model. So generally we tend to improve and not to go back and say, hey, yes, but for this label, let's forget about the accuracy.
Or maybe the API can have just an additional parameter, not just to attach to a specific subversion.
Yeah, it will be a little bit hard because then you have to create a repository of models, naming them. Instead, in AutoML, at least from the interface, you can see here the model you want to use. So whenever you train your model, you give it a name, and right now it's just a name with like.
Yes, with AutoML, I think that the model you build and that you produce, then it is fixed. So I don't think there will be problems with this. I think the problem can be present in the other APIs.
Yeah, but right now, generally, it's like, unless you have very particular corner cases, it's like always better and not like worse than the past.
Yes. Thank you.
Thank you. Any other question?
I have a question which is quite similar to the previous one. Is there a mechanism to get notifications when you build a model with the AutoML, and you can get a better model
Can you better explain, please?
Yeah. If you create a model with AutoML, you have different versions. You can store different versions of your model. But the underlying work that is done by Google, if it improves the way your custom model can be generated, are you notified?
Well, when you create a model, then when you check the different parameters here, sorry, in the evaluate part, and you check for this label and the curves, the threshold curves, this data, you decide what is better. The model simply tells you, hey, this is what I'm able to do. Then, based on your needs, you decide this model is better than the other. Maybe it's more accurate on some labels, less accurate on another label. So the fact that the model is better is something that you and only you decide. Google tells you, okay, with the data you have provided me and with the knowledge I have, this is the best model I can provide you in terms of trade-off between precision and recall and other parameters. Then it's up to you to decide if this model is better than another that you have already trained in the past. Because again, the good model is something that at the end you have to define.
Okay, maybe, but if your knowledge is improved in the meantime, do you notify me?
Yeah, I don't know, one notification every second. Yeah, no, I would say I don't know how identify the part that we have improved and how to notify you and why.
Okay.
But let's talk offline, so we have room for other questions. But yes, let's talk later.
Hi. I was wondering if there is something like AutoML JSON, AutoML something.
What do you mean with AutoML JSON?
I push a table of data.
Okay.
I attach a label to each row, and then I build a model.
No, right now there is just the vision part. So what you can do is you have an image, you recognize labels on the images, on the labels on the image. In the future, maybe new, as I told you in the roadmap.
I mean something more abstract.
Right now, this is what Google is providing to the external world.
Okay, thank you.
Can you export the models and use it on a standalone system?
No, as far as I know right now, no. Maybe in the future, yes, I don't know.
Thank you.
Still, again, it's still an alpha, so you know very well that from alpha to production, several things can happen. Okay, any other question? Okay, do you want to see like how the video intelligence works? Just a quick glimpse. So this is, again, an application made to showcase this video recognition API. So you have a set of videos, and for example, you can go in this video and say, okay, tell me what you see in the video. And you have the different labels here. And for example, I want to see where camels are. You click here, and you go straight to where the camels are. But there are also here. Probably, if I click here in the between, there are no camels. But if I search for pyramid, of course, it's a video in Egypt, so there are a lot of pyramids. You go straight where these pyramids are. So this is very useful to recognize different parts of the video. Then there are also, as you can see sand. Yes, a lot of sand. Camel-like mammal. This is an interesting and different label than before. And so on. Cool part is that if I go in my video collection and, for example, I search about dog, I remember I have a video where there is some dog inside. For example, I click here. Let's see where the dog is or are. Dog. Okay. Boom, here the dog. Okay, so in a video that has nothing related to the dog in the title, in the description, whatever, if there is a dog inside, you're able to detect it. Okay, and you can do this for a variety of other things. If you want to try Vision API by yourself, you can go to the website, and there is an easy interface, web interface, where you can upload your images and recognize labels. You can, for example, check where this image in the web is. So if you have a particular image, maybe you have the copyright of it, you can check if it is used anywhere else in the web, okay, or with similar images. You can check for properties like the dominant color. This is very good if you want to find similar images. Okay, let's find images with similar colors. You analyze the dominant colors, and then you search for images with similar dominant colors. And of course, this is the final JSON with all the information that you want. Again, we are the previous example. As you can see, a lot of information. And if we navigate this cloud, there are different images. Let's see for flowers. Yes.
Since there are so many features in algorithm of videos and is that going to be a language for interrogation of feature like, I don't know, something like SQL?
Well, right now, it's the API format defines the language used to call the API. So there isn't a standard across the different APIs. Maybe in the future, maybe. But basically, if you want, you can build your own like databases of, you have your set of videos, okay? You run the API to these videos, and you get the results. You put them on your backend, and you can query this information in your backend in order to obtain the video. This is more or less what is done in this example here. Okay, so this is just a set of video, and of course you can add more, but whenever you add a new video, a query is done, a database is updated with all the meta information extracted by the API, and then you can do searches and this kind of stuff. Okay, last time for the last question. 3, 2, 1, 0. Okay, thank you.